All right, so I'm going to make a simulation of a card game here. The game rules are pretty simple. 3 cards are going to be selected from a deck without replacement. So I'm going to pull them out, pull the second one out, pull the third one out, not putting them back in. All right, now a little bit of setup that I've done beforehand. 3 random numbers along the top, random number, random number, random number. And then card 1 is going to be written in this green bit. Card 2 is going to be in this orange bit. Card 3 is going to be in this yellow bit. I've also created another tab called my VLOOKUP tab. Now, let's look at it. Numbers 1 to 52. That creates what's called a unique identifier for each card. Now, I've given each card a rank from 1, which is the ace, up to 13, which is the king. I'm going to use the numbers 1 to 13 just because I think it's easier than putting A, J, Q, and K in there. I've got suits, so these are all the hearts, and then we repeat 1 to 13 for all the diamonds, and then we repeat 1 to 13 for the clubs, and repeat 1 to 13 for the spades. And then I've also put in colours, just in case I need them, all the reds and all the blacks. Now, each of these cards has a unique identifier, like I said. So, for instance, the number 33 corresponds to the 7 of clubs, which, of course, is a black card. This VLOOKUP table is going to be really handy. All right, I'm going to jump into my simulation here. I'm going to create my first card by picking a random number between 1 and 52. All right, so random number of 49. That's going to be my first card. And I'm also going to create these two. So that's a random number between 1 and 52. That's a random number between 1 and 52. And that's a random number between 1 and 52. Now, 6, 16, and 28. The 3 cards I've chosen in my VLOOKUP table are 6, which is the 6 of hearts, which is a red card. 16, which is the 3 of diamonds, which is a red card. And 28, which is the 2 of clubs, which is a black card. So now my goal is to make those cards appear in card 1, card 2, and card 3. And it's all done using something called a VLOOKUP. So here, I'm going to do equals VLOOKUP. I'm going to look up my random number in the table. So now I need to choose the table. Okay, there we go. Just highlight the whole table there. Now, I'm going to need to put dollar signs around the A, the 2, the D, and the 53 there. Those dollar signs just mean that as I drag this thing around, the VLOOKUP table stays that. If I didn't put the dollar signs, then the VLOOKUP table would drag down as I drag down my formulas. So dollar signs around your VLOOKUP tables always. Okay, now column index number. So I'm looking up one of the columns. I've got 1, 2, 3, 4 columns. Now my lookup value is always in the first column by default, and then the column that I want to look up is number 2. And then here, am I looking for an exact match or an approximate match? I'm looking for an exact match because I'm going to spit out exact numbers here, 1 to 52. So false. All right, and you can see the random numbers have shifted again. So I've looked up the number 27. If we look at the number 27, let's see that our formula is working. You can see that the number 27 is a 1 of clubs. It's a black card. It's an ace of clubs. And it's spitting out the number 1. Now, I'm going to use almost an identical formula here. This is going to be my suit. So I'm going to copy that formula over, but then I'm going to have to make some adjustments. So A2, I still want to be looking up my first random number because my first random number is my first card. There's my VLOOKUP value. But this time I want to look up column index 3 because column index 3 is the suit. All right, and you can see that it's spitting out now the 13, the king of clubs. And I'm going to take that formula and paste it over here. And that's going to spit out the wrong value because I need to look up, I want to look up A2 still. And I want to look up column 4 this time. All right, so the 4 of hearts, which is a red card, that's my random number 4. All right, now I just need to take that formula and apply it to card 2 using this random number and apply it to card 3 using this random number. So I've done that now. I've got 3 random numbers here, 42, 23, 47. I've got my 3 cards here, the 3 of spades, which is black, the 10 of diamonds, which is red, the 8 of spades, which is black, and if I just type anywhere, those random numbers are going to keep changing and new cards are going to keep getting spat out. You can see those cards are all changing. Okay, now where to from here? Well, there's a problem here because I want to do cards, I want to do a deck without replacement, but there is a small chance that these random numbers, like the random number here and the random number here, are going to be the same. So if the random number here and here are the same, I have a problem. If the random number here and here are the same, I have a problem. So I'm going to do a little test to see whether that's actually happened or not. Test to see if there are repeats. I've just shoved everything over there a little bit. Here's how I'm going to do the test. Now, there's 100 different ways to do this, but this is how I'm going to do it. Equals count if this range is equal to this number. All right, this is going to be a bit weird. So I'm going to put some dollar signs around this. You'll see why in a second. Okay, what's that doing? That's counting the number of RN1s, random numbers. So that's counting the number of 41s in this range. And you would expect that if all of those are unique, there's only going to be 41. Now, if I drag it over 2 more times, what am I doing now? Well, here, I'm counting the number of those that appear, the number of 3s that appear. Then I'm counting the number of 4s that appear. And I'm counting the number of 6s that appear. There's 1, 1, and 1. And now I'm going to do something sneaky. I'm going to do equals this times this times this. Okay. Oh, hello. What happened there? You can see we've got a 52, a 37, a 52. There's a repeat. And if there's a repeat, obviously one of these numbers is going to be 2 or 3, which means that the multiplication is going to be more than 1. Whereas, let's do another one. Here you can see the multiplication is just 1. All right, so I'll just add one more column of blue stuff here. Is it a repeat? Question mark. Equals. If this equals 1, then it's not a repeat. No. If it is, if it's more than 1, if it's not 1, then yes, it's a repeat. No. Oh, there was one. Doesn't want to do another one. I'll do one manually. Okay, let's do a repeat. 21, 21. Oh, there you go. There's a repeat. And you can see now I've got a neat way of calculating whether something is a repeat, yes or no. So there's my test for repetition, and that's how I'm going to deal with it. I'm just not going to count the rows. So if I drag down now, oh, okay, I see what's happened. Now I just need to make sure my count ifs. I need to take the dollar signs away from those 2s. Because I need it to follow me down as I do cell to cell to cell. Okay, so now that should work. Okay, you can see no repetition so far. Oh, there's some repetitions. There's some repetitions. 10, 10, 43, 50, 21, 21. Okay, now I'm not going to keep those rows upon rows upon rows. I'm just going to delete them. I won't drag that down until the end. Okay, so that's my test for repetitions. I'll drag that blue stuff over and then we'll get started on some winning outcomes. Test now to see if it's a 3 of a kind. If all 3 of these numbers, so you can see we've got a 5 of spades, a 5 of spades, and a 12 of clubs, 12 of hearts at the moment. we're going to see if it is a 3 of a kind. If all 3 of the numbers are the same, 5, 5, 5, 12, 12, 12, ace, 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 whatever it might be. All right, so it's going to be pretty simple to do that. It's another count if, I think. Count if. We need our range. My range is going to be a bit funny. Attention that this is going to be a little bit annoying because I want to do a count if on a range, but doing a count if on a range where one of the cells is here and one of the cells is here and one of the cells is here, not next to each other, is a bit of a pain. So I'm going to cheat and just make them next to each other by putting them into 3 new cells. So I'll make that cell equal that one, I'll make that cell equal that one, and I'll make that cell equal that one. And those now are just like, I'll call them the card ranks. You notice I'm trying to label everything as I go here because I'm just going to get confused if I don't keep reminding myself of what everything is. Okay, now I can do a count if. Equals count if this range, and I'm going to use my dollar signs correctly this time, just on the letters. I'm going to say count if they're all the same as that first number, because obviously if all 3 of them are the same, then they're all going to be the same as that first number. Do I need any dollar signs? Nah. Okay, done. All right, so yeah, is it a 3 of a kind? So you can see it's counting and it's saying 1. That means there's 1 13 card there. Let's keep going. Let's just do a few more iterations. See if we can ever get one that's... Oh, there we go. It's saying 2. Okay, now there's a 13 there and a 13 there, but that's not 3 of a kind. So for it to be 3 of a kind, that number there needs to be equal to 3. So let's do a little if statement. Equals if this equals 3, then is it a 3 of a kind? Yes, it is. Otherwise, no, it's not. Okay, and let's just see if it works. I'll just type in some numbers here. 23, 23, 23. Oh, hello. All the card ranks are the same. Is it a 3 of a kind? Yes, it is. All right, so that's my first test. I can do a pair now pretty easily. Is it a pair? Now, that's going to be a little more tricky. I can do equals if this, what can I do? If this equals this, I'm going to say 1 and 0. So that just means if that cell equals that cell, then I'm put a 1 in there. If that cell equals that cell, I'll put a 0 in there, whatever. I need to do that kind of for all pairs. So it'll be equals if the first one equals the third one, 1 or 0, and equals if the second one equals the third one, 1 or 0. Okay, so is it a pair? No, no, no. Let's see if I can get a pair appearing somewhere. Oh, there's a pair. Okay, so you can see 3, 12, 12, that one's a pair. So I can now create a formula here that basically says if any of those is a 1, then it's a pair. So I can just write equals. I'm going to do something a bit funky here. I'm going to say if the sum of these 3 things is, I need to do like an if sum. Okay, let's try again. I need to say if the sum of these things equals 1, then yes, it's a pair. Otherwise, no, it's not a pair. Okay, now you can see no, it's not a pair. Let's see if we can get a pair appearing. Oh, there it is. 11, 11, 1. Now, why have I done such a strange test? If the sum of those is equal to 1, because what if there was a 1 here and a 1 here? Well, if there was a 1 here and a 1 here, the sum of them wouldn't be 1, the sum of them would be 2. But if there was a 1 here and a 1 here, it wouldn't be a pair. It would be a 3 of a kind. So actually, I probably could have just not done this 3 of a kind calculation at all. I could have just done a pair calculation and then just said if it's sum 1, then that's a pair. If it's sum 2, then that's a 3 of a kind. But regardless, I've got it now, so I'm going to leave it there. It's just not as efficient as it could have been, I suppose. The flush or the same suit, the way that I'm going to do that is in this yellow here. I'm going to count up how many R's there are, how many D's there are, how many B's there are, and how many C's there are. Now, in order to do that, I'm probably also going to want to do a little card suit bit here. So B equals, not B, sorry. I want the suit of the first card, so the card suit hearts. I want the card suit of the second card, diamonds, and I want the card suit of the third card, spades. Okay, so DCC, DCC, C1, C2, and C3. That's card 1, card 2, and card 3. Oh, hello, I've got a flush. Okay, so now I'm just going to do like count ifs again. Equals count if this range, and I'm just going to $ the letters. You just need to do now that I'm in AF, you just need to $ the first letter. And what's my criteria? Well, I want it to be the letter R, and I'm going to need to use $ the number now, because when I drag it down, I want it to stay using row 1 as its guidance. Okay, you can see there's no R's there. Now, if I drag that across, that's counting the number of D's. Oh, why am I getting an S? Oh, because I shouldn't have B's there. I should have S's there. Okay, there we go. And I shouldn't have R there. I should have H's there. Hearts, diamonds, spades, clubs. All right, so you can see it's counting 1 heart. It's counting 2 clubs at the moment. Just do a couple of tests. 2 diamonds, 1 club, 2 hearts, 1 spade. All right. Is it a flush? Okay, now, is it a flush? How can we figure out how to test these? We just want to know that if a 3 appears. All right, so equals count if in this range. I just want to count it if the number 3 appears. All right, let's see. See if we get a flush. Bound to happen sooner or later. Obviously, it's not very likely. Oh, there we go. Is it a flush? 1. All right, I'm going to take that as a win. I'm just going to treat the 1 as a yes. Is it a flush? We now have 3 tests. I just need my royal test. All right, so I wonder if they're all royals. I have to do some sort of count if equals count if. This one might be challenging. I'm going to do like okay, so the range is easy. I'm just counting the ranks there. Now the criteria. Now, because of the way I've set this up in the beginning, a jack is an 11, a queen is a 12, a king is a 13, and an ace is a 1. So I'm going to have to do some sort of like OR situation. I probably could do some sort of like mod arithmetic, but I'm just going to use OR instead. Okay, equals OR. All right, so my logical test 1 is greater than 10, and my logical test 2 is 1. Now I think I need like quotation marks around those things. I think. All right, that's my OR statement. I think I'm done. Okay. No good. You would hope, I've written greater than 10, and I was hoping for, I've got a 13 there, which means I should be counting it, but I'm not counting it, so I've stuffed something up. Good way of doing this, count if the cells I'm interested in, the 3 ranks, are greater than 10. But then I'm also going to add the count if that the cells I'm interested in are equal to 1. Equal to 1. Okay, let's see if that was working. All right, I'm getting a 2 there. I'm getting a 1 there. That's from the ace. I just want to see one with an ace and a king on it. No. This doesn't happen when you want it to happen, does it? I had to try a few times, but you can see here I've got the ace and the 11. That's counted as 2 royals. So now I just need to do my test. I want all royals. So equals if this equals 3, the value if true. Yes, royals. Value if true. False. No. That's all my tests. I'm done. Really now I just need to like drag it down and then do some counting, and so then there's something really important that I need to remember with the counting. First step, I'm going to take everything I've done now, drag it down. Now I don't recommend you did what I've done. You should probably sort of drag it down periodically to make sure that your cell references and things work as you drag them down. But I was feeling pretty confident there. All right, you can see, yes, we can see some things happening there. Is it 3 of a kind? So that's pretty unlikely, it seems. I can't see any 3 of a kinds at the moment. I might just run another trial. See if we get some 3 of a kinds appearing. Still no. Still no. Oh, there's one. All right, so 3 of a kinds are appearing. Pairs are appearing. Flushes are appearing. And royals, you can see one appearing up the top there. I'll just get rid of my game rules. I don't need them. Drag them over there. Don't need that one. I don't know what that's doing there. Now it's time to do some counting. Definitely want to insert a couple of rows up the top to help us with our counting. I don't know how many I need, but it might be useful to have a few. And now we just do some counts. Okay, so first thing I'm going to do is look at these repeats. I'm going to do a count if the range. Actually, let's just figure out how many you've got altogether, first of all. So I'm just going to count the number of cells. So these are the number of trials that I've performed. Oh, I've performed 99 trials. That seems stupid. Let's drag it one down one more, and that'll mean I've done 100. Okay, and just 104. Okay, now let's see how many times how many I should ignore because there's a repetition in them. And remember, we were doing decks without replacements. So this was my row where I was testing for repeats. Count if in this range criteria. I'll type in no as my criteria. Okay, 99. So that means I did 100 trials. 99 are valid. One of them has a stupid repeat in it. I'll just run it a couple of times so we can see how often that happens. 96, 98, 92, 92, 92, 92, 94, 97, 93. So you can see in 100 trials, I get like 5 or 6, maybe even 8 repeats pretty regularly. So those repeats are a real problem and we need to account for them. So for the first time ever, I'm going to do not a count if, I'm going to do a count ifs equals count ifs. And this allows me to count a cell based on 2 criteria from 2 different ranges. So first off, I'm going to count the 3 of a kinds. So that's criteria range 1. And I'm counting it if it just says yes, right? Okay, let's see if I can get a yes to appear at some point. All right, there it is. So there must be a yes down the line here somewhere. There it is. 3 of a kind. Okay, now here's the problem. I've counted it, but what if that yes is one of the repeats? Let's see if it is. Oh, it is a repeat, so I shouldn't be counting it. It's a bad thing to count. So here's how I'm going to get around that. I haven't used COUNTIF, I've used COUNTIFs. So now I'll choose my second criteria range, which is this one. And I need it to be no. If that one's no, that means that no, there were no repeats. And I'm also counting yes if there was a thing. And so what it's doing is counting this cell and this cell, this cell and this cell, this cell and this cell, and making sure that this one is yes and this one is no. Okay, that's not going to happen very often at all. You wouldn't expect in 100 trials. I don't know what the probability is because I haven't done the theoretical. Oh, there it is. Let's see what that is. I need to be careful here. So it's a 3 of a kind, so there's a 1. Let's see where it is. Okay. There's a 3 of a kind there, and there's a yes there. So that one we shouldn't be including. We shouldn't be counting that one. But there's a yes there and there's a no there. We can count that one. So there were 2 3 of a kinds, but only one of them was a true 3 of a kind. So we've only counted one of them using that nice little COUNTIF. Now I can also do now that we've seen COUNTIF, we can use COUNTIF for all of our statements. So I'm going to do count if it's a pair. Now I can actually just use that same formula. I just need to be careful about what cells it's referencing. Okay, let's see. It's referencing AB5 to AB104 and yes, and it's referencing V5, but I don't want it to reference V5. I need it to count the repeats, which is Q5, Q104. Okay, now that is counting the number of pairs, so you can see that's a yes pair, but with a no repeat. That's a yes pair, but with a yes repeat. So it's not going to count that one. It's only going to count the yes nos. Okay, is it a flush? Count ifs. This criteria range. This time I used the number 1 instead of yes, so it's not very consistent. The other criteria range I need to consider is this one. And we're only counting the no's. 4 flushes and count ifs. The royals. Yes. The repeats. No. All right. So what do I have? No 3 of a kinds, 13 pairs, 5 flushes, and 2 royals. Now, I've got small issues here that I haven't accounted for yet because maybe something's a pair and a flush. What's a better thing to have? Because if it's a pair and a flush, then I shouldn't count it. Now, I can fix that with multiple count ifs. I can count it if it's a pair. I can count it if it's not a repeat. I can count it if it's not a flush. I can also just subtract various things from each other, but I need to be careful about how I do that. All right, so I'm not going to correct for that at the moment. That's a job for you to figure out how to do multiple count ifs to get rid of your exclusions for your flushes and your pairs and things like that. What I can now do is find the probabilities of these things happening. It's simply that divided by that. I'm going to need some more decimal places, obviously. 15% chance of getting a pair. 4% chance of getting a flush. 4% chance of getting a royal. Now, obviously, these are... I'm only doing 100 trials here. I'm not doing very many at all. Now, 3 of a kind. At the moment, it's not happening very frequently, obviously. It happened once then, 0 times, once then, once then, once then. So maybe there's like a 1 in 200 chance of it happening or something. I'm not sure. Okay, and finally, I can calculate payouts, expected values if I wanted to as well, just by multiplying those numbers by how much people are investing, how much they're getting paid back. Whoa. Okay, that's 30 minutes. That's my game. I've been a little bit lazy with my count ifs there. I've counted if it's a repeat, but I haven't counted the overlaps between the pairs and flushes. But count ifs is the key to that. Otherwise, that's it.